Lastly, I'm going to attempt to explain why my function exhibits this odd behavior, which has a quadratic function with an oblique asymptote with the function on both sides of or on the same side of the asymptote. So what we see here in my equation, right there, is that we have a 2x squared on the top and the bottom. And we see that these will cancel out, and you'll be left with a Lie coefficient of x cubed over negative 3x. When you divide x cubed by a 3x, you are left with a quadratic, and these being cancelled out will give you this quadratic shape. And what this will leave you with is your quadratic shape here at the bottom, with your you will still have that oblique asymptote. However, you will have in shape like this. And also, as previously showed, you will have division, and when finding the oblique asymptote, there was a large remainder. When having this remainder, we saw that there was actually the equation of the remainder was actually larger than that of the asymptote. So with that large remainder, we see that because what you have would be the equation of the line plus the remainder. So we see that because the equation of the remainder is so large, it's actually going to pull the line or the function above the asymptote. So we see it's going to increase because on both sides. And because we have the equation of the remainder was 8.75x plus 25.5 over 2x squared minus 3x minus 10. So what we're going to see is that around values of 3, 3 times 8, you're going to have 24, which is your Lie coefficient, and which 3 to the power of 2 is 9 times 2 is only going to be 18. So we see that there's a very large number on the top compared to the bottom, and you're going to be adding a large number of 3. So if we go to 3, approximately here, we see how much that remainder is actually going to pull the equation above that oblique asymptote. And this is why the function exhibits this type of behavior.